I know because of this form here that this is exponential. Remember, usually the exponential form is y is equal to a times b to the x, or another way it can be written is ya b to the x. This is the same thing, same thing. So since I see it in this form, I know this is exponential. Okay, right away I know this is exponential. So that's what I'm going to be doing. I'm going to put exponential. Now, if this is exponential, the functions change by ratios over equal intervals. Remember, whenever it's exponential, you're going to be multiplying or dividing by a certain number. That's a ratio, okay? Now, if it's a linear function, which we might see in other problems, a linear function, that's going to be common differences, right? Adding and subtracting, common differences. But here, exponential, remember, is multiplication. So whenever you see exponential, you're going for multiplication division, which means common ratios. And finally, when the x value changes by 1, okay, the function's value changes by what? Now you can go over here and see what it's multiplying by, but look, remember that this is right here. This is, and I'm going to put fireworks here, that is your key part right there. That is right here a common ratio. That is what you're multiplying by. So we're going to go by a factor. That's your common ratio, your common factor of 3/2. Okay, so these are key points. All right, here we go. So for this problem here, we have complete the sentences about the functions f of x, 6x plus 9, and g of x, 3 times 3 of x. So right away from what I can see here, I see this is linear. I just like writing things down just so I can see what's going on in the problem. And we have an exponential. Exponential, right over here. For the small values of x, the function with greater values is, well, when the numbers are small, f of x is going to be bigger. For small values of x, the function with greater values is f of x. In the beginning, the linear functions are usually bigger in the beginning. Now, if we want to check, we can do that. We can do that table. F of x, 6x plus 9. Here we have g of x, 3 times 3 to the x. So in the small numbers, 0, 1, 2. Here, if I plug in 0, I get 9. If I plug in 0 here, 3 to the 0 is 1, times 3 is 3. So right now, f of x is winning. The linear function is winning. If I plug in 1, I get 15, and I get 3, 1 is 9. This is still bigger. If I plug in 2, 12, 21, 9, 20, this is 9 times 3 is 27. So for the small numbers, in the beginning, the f of x values were bigger. So over here, they were bigger. It was bigger right over here. For instance, let's see what we have. F of 0 is 9. We figured that one out. Whereas g of 0 is 3. G of 0 is 3. Look, we did that. As the values of x increase, however, the g of x will eventually be bigger. Look, as you got bigger, 2, 3, 4, the bigger you get. Look, but even at 2, we plug that in. Now g of x is 27. This is 21. Now all these other values, they're going to be bigger for the g of x because that is your exponential. So remember, in the beginning, linear usually, not every single time, but most of the time is going to be bigger and the exponential is going to be smaller. But once you get into the bigger numbers, exponential is always going to win. It's going to win. See what we got? Beautiful. All right, here we go. All right, let's see what we have here. Again, I'm looking at this. I have exponential, right? Because we have the x and the exponent. Over here, we have a linear function. In the first few values, as we can see, the linear function is bigger. Look, in the beginning, it's bigger, bigger, bigger. And then later on, look, even up to 5, this is 32, and this is 40. But don't worry, as the numbers get bigger, trust me, you put a bigger number there, the exponential function is going to be bigger. But let's see what they're asking us here. All right, so as the value of x increases, the value of f of x will eventually be greater than the value of g of x, because f of x grows. F of x, how is f of x growing? We know this is exponentially, and g of x grows linearly. Again, all of these problems, they just want you to know how to compare linear functions to exponential functions, okay? So just take your time, read the question, and look, sometimes I like labeling things before I even get into the problem, before I even get in there. So even here, right away I put exponential. I write something down. Here, I know this is linear. Right away, that helps me because look, here that would have helped us. F of x grows, look, I have it written down. Exponentially, g of x is linear. So you already have 2 out of 3 out of the way. And we know the main idea, I keep repeating myself, I know that, but the main idea is that the exponential, or the f of x in this scenario, will eventually be greater than the g of x, or the linear one. Now, don't get confused. In other problems, they might switch to linear and exponential to try to throw you off a little bit. That's why you have to make sure you label. I like labeling. This is exponential, this one's linear, because I know which one eventually is going to be bigger. So make sure you label. Label definitely helps out a lot. All right, let's see what we have here. All right, so the graph shows an exponential function whose domain is set of the integers. So look, we have this graph here. You can connect the dots here. Right away, this is not a straight line, not a straight line, so I know this is exponential. Okay, I know it's exponential. All right, it starts off small, 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 and then eventually it moves much, much faster, as you can see here. Write an equation. Okay, so this is a popular one, and it tells you the format. Write the exponential function in the form f of x, which again, you can also write down as y. It's another way of writing down. Y is equal to a, which is our initial value where we're starting, times b to the x, a times b to the x. Remember, a is your initial value, initial, or your y-intercept. Okay, it's where you're starting or your y-intercept. Okay, and your b is your common ratio. Ay, ay, ay. It is your common ratio. All right, so here we go. Let's get started. So I think the easiest thing to identify right away is the initial value. The initial value, it's right over here. It's your y-intercept, and I can see that's at 0, -1. So I can see that my initial value is -1. So right away we have y is equal to -1 times, now we just need to find our common ratio. Now the common ratio is, remember, it's what you're multiplying by to get to the next number for your y value. So I have 0, 1, that's my first one here. I have 1, -3, 1, -3, and I have 2, -9. I like writing it down like this because it's a little bit easier to see, or you can even do x, y, 0, 1, 1, -3, 2, -9. Okay? So I know I need to find the pattern here. I already have my initial value from here to here. What am I know it's multiplication or division because it's exponential. So what am I multiplying by every single time? This is -1. I'm sorry about that. -1. So what am I multiplying by here? I can see that I multiply it times 3 times 3. So my common ratio is 3. 3 to the x. So that's what I do. I try to identify a couple of points. You can do it here. You can say -9 divided by -3. That's 3. You could have done it that way. But some people, it's hard to just picture this way. They like seeing the table. It's a little bit easier to view, a little bit easier to understand. So I also like the table. So I write down my points in the table. I see my relationship times 3 times 3. That is my common ratio. And earlier we found the -1 to be my y-intercept. So let's type that in. All right, we got -1. And I know before, and I saw, I believe they were writing it like this in the parentheses, 3 to the x. To the x here. There you go. So So I hope this video helps out. If you need a few more examples, please let me know. Please either comment or email me. Please let me know if you need another example. If certain colors don't work well on the screen or don't look as well, also let me know. I'm trying to get better at this. So please let me know what works best for you. And thank you very much.